Have you ever wondered how a fist-sized organ keeps you alive, pumping blood tirelessly through 60,000 miles of blood vessels every single day? Let's unravel the incredible science of the human heart, a true marvel of nature. The human heart is more than just an organ. It's the engine that powers our very existence. It's a symbol of love, courage, and vitality. Throughout history, the heart has been revered in art, literature, and culture. But beyond symbolism, it's a vital organ, a tireless worker that keeps us alive. Every beat is a testament to its relentless dedication. This fist-sized powerhouse pumps blood throughout our bodies, delivering oxygen and nutrients while removing waste products. It ensures that every cell receives what it needs to function. Understanding the heart's anatomy is crucial to appreciating its remarkable function. Each part plays a specific role in maintaining our health. From the moment it starts beating until our last breath, it never rests. Nestled slightly to the left of our chest's center, the heart is a compact organ, roughly the size of its owner's clenched fist. Don't let its size fool you though. This muscular pump generates enough pressure to circulate blood throughout the entire body. The heart's location is strategically important. It's positioned within the rib cage, offering protection from external impact. This bony shield safeguards one of our most vital organs. The heart's central location also facilitates efficient blood distribution to all body parts. The heart is divided into 4 chambers, 2 on the left and 2 on the right. These chambers are essential for the heart's function, each playing a unique role in the circulatory system. These chambers work in perfect sync to keep blood flowing in a continuous loop. This synchronization is crucial for maintaining the body's homeostasis and ensuring that all organs receive the oxygen and nutrients they need. The upper chambers, called atria, receive blood returning to the heart. They act as holding tanks, ensuring that blood is efficiently passed to the lower chambers. The right atrium receives deoxygenated blood from the body, while the left atrium receives oxygen-rich blood from the lungs. This separation ensures that oxygenated and deoxygenated blood do not mix, maintaining the efficiency of the circulatory system. The lower chambers, called ventricles, are the heart's powerful pumps. They are responsible for propelling blood out of the heart and into the lungs or the rest of the body. The right ventricle pumps deoxygenated blood to the lungs to pick up oxygen. This process is vital for reoxygenating the blood, which is then sent back to the heart to be distributed throughout the body. The left ventricle, the strongest chamber, pumps oxygen-rich blood to the rest of the body. Its powerful contractions ensure that blood reaches even the most distant tissues and organs. The coordinated contraction and relaxation of these 4 chambers ensure a constant blood supply. This intricate dance of the heart chambers is what keeps us alive, providing a continuous flow of life-sustaining blood. Between each atrium and ventricle, and between the ventricles and the major arteries, are heart valves. These valves play a vital role in the cardiovascular system, ensuring that blood flows efficiently and correctly through the heart and to the rest of the body. These valves act as one-way gates, ensuring blood flows in only one direction. This one-way flow is essential to prevent backflow and to maintain the proper pressure needed for effective circulation. The tricuspid valve regulates blood flow between the right atrium and the right ventricle. It opens to allow blood to flow from the atrium to the ventricle and closes to prevent it from flowing back. The mitral valve controls blood flow between the left atrium and the left ventricle. Like the tricuspid valve, it ensures that blood moves in the correct direction, preventing any backward flow. The pulmonary valve ensures blood flows from the right ventricle to the pulmonary artery and on to the lungs. This valve is crucial for directing deoxygenated blood to the lungs for oxygenation. Finally, the aortic valve regulates blood flow from the left ventricle to the aorta, the body's main artery. This valve ensures that oxygen-rich blood is delivered to the entire body. These valves are crucial for maintaining proper blood circulation. Without them, the heart would not be able to function effectively, leading to serious health issues. They work in harmony to keep the blood moving efficiently through the heart and to the rest of the body. Now about the layers of the heart wall. The heart wall is composed of 3 distinct layers, each serving a unique function. The endocardium forms the innermost layer, lining the heart chambers with a smooth surface that facilitates efficient blood flow. Surrounding it is the myocardium, a thick muscular middle layer responsible for the heart's powerful contractions and pumping action. Encasing the heart wall is the epicardium, the outermost layer, which forms part of the protective pericardium. The left ventricle has the thickest walls because it pumps blood throughout the body against high pressure. The pericardium is a double-walled protective sac that surrounds the heart. It plays a crucial role in safeguarding the heart, anchoring it securely within the chest cavity and housing a lubricating fluid that minimizes friction as the heart moves continuously during its rhythmic contractions. How does the heart receive its blood supply? The heart muscle or myocardium receives oxygen and nutrients through the coronary arteries, branching from the aorta. Deoxygenated blood from the heart muscle is drained by the coronary veins into the right atrium via the coronary sinus. How does the heart beat? The heart's rhythmic contractions, or heartbeat, are controlled by its intrinsic electrical conduction system, which ensures the heart pumps blood effectively and maintains a steady rhythm. First, sinoatrial node or SA node. Often referred to as the heart's pacemaker, the SA node is located in the upper wall of the right atrium. It generates electrical impulses spontaneously, setting the heart's pace at normal resting rate, 60 to 100 beats per minute. These impulses spread through the atria, causing them to contract and push blood into the ventricles. Second, atrioventricular node, or AV node. Situated between the atria and ventricles, the AV node acts as a gatekeeper. It slows down the electrical signals before they pass to the ventricles, ensuring the atria have enough time to empty their blood into the ventricles before ventricular contraction begins. Third, bundle of His. This specialized bundle of fibers, located in the septum between the ventricles, carries the electrical signals from the AV node toward the ventricles. The bundle of His splits into 2 branches. Right bundle branch sends signals to the right ventricle. Left bundle branch sends signals to the left ventricle. Fourth, Purkinje fibers. These fine fibers branch off the bundle of His and spread throughout the ventricles. They transmit electrical signals quickly, causing the ventricles to contract and pump blood out. Right ventricle pumps deoxygenated blood to the lungs via the pulmonary artery. Left ventricle pumps oxygenated blood to the body via the aorta. The electrical conduction system ensures the heart's two-step rhythm. First step, atrial contraction. Triggered by the SA node, the atria contract first to fill the ventricles with blood. Second step, ventricular contraction. Guided by the AV node, bundle of His and Purkinje fibers, the ventricles contract to pump blood to the lungs and the rest of the body. In a healthy adult at rest, the electrical system maintains a regular heart rate of 60 to 100 beats per minute. During exercise or stress, the SA node increases the heart rate to meet the body's heightened oxygen demand. Conversely, during relaxation or sleep, the SA node slows the heart rate. Why it's important? A properly functioning electrical system ensures the heart works in a synchronized and efficient manner. Disruptions in this system can lead to arrhythmias or irregular heartbeats, which may require medical intervention such as medications, pacemakers, or defibrillators. This delicate interplay of electrical signals highlights the sophistication of the heart, a vital organ that tirelessly supports life. The heart is the engine of the circulatory system, tirelessly working to pump blood, oxygen, and nutrients to every part of the body while removing waste products. Its role is vital for sustaining life and is carried out through two key circulatory systems. First, pulmonary circulation. The right side of the heart receives deoxygenated blood from the body through the superior and inferior vena cava. This blood is pumped into the lungs via the pulmonary arteries. In the lungs, carbon dioxide is expelled and oxygen is absorbed. The right atrium receives deoxygenated blood, while the right ventricle pumps blood to the lungs. Outcome? The blood becomes oxygen-rich and ready to nourish the body. Second, systemic circulation. The left side of the heart collects oxygen-rich blood from the lungs through the pulmonary veins. It pumps this blood to the rest of the body via the aorta and smaller arteries. Oxygen and nutrients are delivered to tissues, and waste products, like carbon dioxide, are carried away by veins. Left atrium receives oxygenated blood from the lungs, while left ventricle pumps oxygen-rich blood to the entire body. Outcome? The body receives essential oxygen and nutrients, and waste is transported back to the heart. How efficient is the heart? The heart beats approximately 100,000 times daily, working seamlessly without pause. At rest, the heart pumps about 5 liters of blood per minute. During exercise or heightened activity, this output can increase dramatically to meet the body's needs. Why is this function critical? The heart's dual circulatory systems play a crucial role in maintaining the body's homeostasis by ensuring the oxygenation of every cell, providing the oxygen required for energy production. Simultaneously, it facilitates the delivery of vital nutrients, such as glucose and amino acids, to various tissues, supporting their growth and repair. Additionally, it manages waste removal by transporting carbon dioxide and other metabolic byproducts away from the tissues, directing them toward excretory organs for elimination, thereby maintaining a balanced internal environment. This ceaseless coordination keeps the body alive, energized, and functional, highlighting the heart's indispensable role in human survival. How is the heart connected to the neuroendocrine system? The heart does not function in isolation. It is intricately connected to various body systems, working in harmony to maintain homeostasis and meet the body's demands. First, nervous system. The autonomic nervous system, or ANS, governs the heart rate without conscious effort, ensuring adaptability to different situations. Sympathetic nervous system activates the fight or flight response during stress, fear, or physical activity, increasing heart rate and force of contraction. Parasympathetic nervous system facilitates the rest and digest state, slowing the heart rate during relaxation or sleep. For example, in a stressful moment, your heart rate increases to supply more oxygen and nutrients to muscles for quick action. Second, endocrine system. Hormones released by the endocrine glands modulate the heart's activity. Adrenaline or epinephrine secreted by the adrenal glands increases heart rate and cardiac output during stress or excitement. Thyroxine T4, produced by the thyroid gland, enhances the metabolic rate and can increase heart rate over time. For example, during intense exercise, adrenaline surges, enabling the heart to pump more blood to meet the body's elevated oxygen demand. These interactions ensure the body adapts to varying needs, whether during rest, stress, or activity. Does the heart really control emotions like love? The idea that the heart controls emotions, especially love, is deeply rooted in culture, art, and language. Phrases like "follow your heart" or "heartfelt emotions" make it seem like the heart is the center of emotions. However, scientifically speaking, the heart doesn't control emotions. The brain is the primary organ involved in processing emotions. The limbic system, specifically structures like the amygdala, is crucial in generating and regulating emotional responses. While the heart doesn't directly control emotions, there is a strong connection between emotional experiences and the physical sensations we feel in our bodies, particularly in the heart. For instance, when you are nervous or excited, you might feel your heart race. This connection is a result of the autonomic nervous system, which regulates involuntary bodily functions like heart rate, blood pressure, and digestion in response to emotions. In the case of love, what we feel as butterflies in the stomach or a racing heart is the body's physical reaction to emotional stimuli. But the emotion itself is processed by the brain. So, the heart isn't the controller of emotions, but it certainly plays a role in how those emotions are physically experienced. Now, let us discuss some common heart diseases. While the heart is designed to endure and sustain life, modern lifestyles, environmental factors, and genetic predispositions often challenge its resilience. First, coronary artery disease. CAD is a condition where the coronary arteries, which supply oxygen and nutrients to the heart muscle, narrow due to the buildup of fatty plaques called atherosclerosis. Reduced blood flow can lead to angina or chest pain and, in severe cases, myocardial infarction, also known as heart attack. Causes: high cholesterol, smoking, diabetes, obesity, and sedentary lifestyle. If untreated, CAD can severely impair heart function, leading to life-threatening events. Second, arrhythmias. Arrhythmia refers to an irregular heart rhythm that may be too fast, called tachyarrhythmia, Too slow called bradyarrhythmia or irregular like atrial fibrillation. The pathology lies in a malfunction of the electrical conduction system of the heart. Triggers include electrolyte imbalances, stress, or underlying heart conditions. Symptoms: palpitations, dizziness, shortness of breath, and in severe cases, fainting or cardiac arrest. Persistent arrhythmias can reduce the heart's efficiency, potentially leading to complications like stroke or heart failure. Third, heart failure. Heart failure occurs when the heart weakens and is unable to pump enough blood to meet the body's needs. This often occurs as a result of CAD, high blood pressure, or a previous heart attack. Symptoms: fatigue, shortness of breath, swollen ankles or edema, and fluid accumulation in the lungs. While it doesn't mean the heart stops working, heart failure significantly reduces quality of life and requires long-term management. So, how can you protect your heart? The heart is at the center of your well-being, and protecting it requires a holistic approach to lifestyle and habits. 1. Prioritize a heart-healthy diet. Your dietary choices significantly impact heart health. A balanced diet should emphasize the inclusion of nutrient-dense foods while limiting those that may harm health. Incorporate plenty of fruits and vegetables, which are packed with antioxidants, essential vitamins, and dietary fiber. Whole grains like brown rice, oats, and quinoa are excellent for reducing bad LDL cholesterol and supporting heart health. Lean proteins such as fish, skinless poultry, legumes, and tofu provide essential amino acids without adding excessive, unhealthy fats. Healthy fats, including avocados, nuts, seeds, and olive oil, are beneficial for promoting good HDL cholesterol levels. At the same time, it's crucial to limit certain dietary components. Keep salt intake in check, as excessive sodium consumption can raise blood pressure, with a recommended daily limit of less than 2 grams. Added sugars should also be minimized, as they contribute to obesity, diabetes, and other metabolic issues. Unhealthy fats, particularly trans fats and saturated fats found in processed foods and fatty meats, should be avoided or reduced to maintain overall health and prevent chronic diseases. 2. Stay active with regular exercise. Engaging in regular physical activity is essential for maintaining cardiovascular health and overall well-being. It is recommended to perform at least 150 minutes of moderate aerobic exercise each week, such as brisk walking, swimming, or cycling. Additionally, incorporating strength training exercises twice a week provides further support for cardiovascular health by improving muscle strength and endurance. The benefits of such a routine are significant. Regular exercise helps lower blood pressure and cholesterol levels. It also aids in maintaining a healthy weight, which reduces stress on the heart and other organs. Furthermore, staying active reduces the risk of developing heart disease and stroke, contributing to a longer and healthier life. 3. Manage stress effectively. Chronic stress strains the heart, increasing the risk of hypertension and arrhythmias. Incorporating relaxation techniques into your routine can significantly reduce stress and promote overall well-being. Meditation is particularly effective as it encourages mindfulness and helps lower cortisol levels, the body's stress hormone. Yoga, which combines physical movement with deep relaxation, is another powerful tool for relieving stress and promoting a sense of calm. Deep breathing exercises work by activating the parasympathetic nervous system, helping to calm the body and mind, reducing anxiety, and improving focus. Alongside these techniques, making key lifestyle adjustments is vital. Setting clear boundaries to prevent overworking is essential for maintaining mental and physical health. Equally important is maintaining a healthy work-life balance, ensuring time for relaxation, personal interests, and social connections, all of which contribute to reduced stress levels and a more balanced life. Fourth, avoid smoking and limit alcohol consumption. Smoking damages blood vessels, accelerates plaque buildup, and increases the risk of CAD and stroke. Quitting smoking improves heart health almost immediately. Excessive drinking weakens the heart muscle, causing alcoholic cardiomyopathy and raises blood pressure. Limit alcohol moderate intake means up to 1 drink daily for women and 2 for men. Lastly, schedule routine health checkups. Regular screenings are vital for maintaining heart health and detecting potential risks early. Monitoring blood pressure is crucial as it should stay within a healthy range, ideally below 120 by 80 mmHg of Hg, to reduce the risk of cardiovascular diseases. Cholesterol levels, including LDL bad cholesterol, HDL good cholesterol, and triglycerides, should also be checked regularly to ensure they are within optimal ranges and prevent plaque buildup in the arteries. Blood sugar levels are essential to monitor as well, since elevated blood sugar can indicate or contribute to diabetes, a significant risk factor for heart disease. In addition to these key screenings, annual doctor visits are important for overall health maintenance. Regular checkups are particularly necessary if you have a family history of heart conditions, as early detection and lifestyle adjustments can significantly reduce the risk of developing heart-related issues. Take charge today. Small, consistent steps can significantly impact your heart's health. Embrace these habits to ensure your heart beats strong and steady for years to come. Finally, some interesting facts about the heart. The heart is the first organ to form during fetal development, starting to beat just 3 weeks after conception, and never stops until death. Over a lifetime, the heart pumps enough blood to fill about 3 supertankers. The heart is about the size of your fist, but it pumps the enough blood to fill a 2-liter bottle every minute. Over a lifetime, it pumps about 200 million liters of blood. Heart beats around 100,000 times a day, pumping blood to every part of your body. That's over 35 million beats a year. The heart doesn't rely solely on your brain to beat. It has its own electrical system, which generates signals that control the rhythm and rate of each beat. This is why the heart can continue beating even when it's disconnected from the body. Unlike many organs, the heart has limited ability to regenerate. While some cells can repair minor damage, severe heart injuries can cause permanent scarring. Researchers are working on therapies to help stimulate the heart's regenerative capabilities. On average, a woman's heart beats faster than a man's. The average resting heart rate for women is around 78 to 82 beats per minute, while for men, it's about 70 to 72 beats. Regular physical activity not only strengthens your heart muscle, but also improves its efficiency. A well-conditioned heart can pump more blood with each beat, reducing the need to work as hard during rest. The average lifespan of a heart transplant is about 12 years. But with advances in medicine, many people are living much longer with transplanted hearts. In essence, the heart is more than just an organ. It's the lifeline that supports every cell in your body. By understanding its incredible mechanics and adopting heart-healthy habits, we can ensure this remarkable engine keeps running smoothly for years to come. Remember, taking care of your heart today is an investment in your future. See you in the next video. Till then, take care of yourself.